This problem is a system of linear equations, and we're going to solve it by starting to graph it. We're doing this one at this point. It's a special situation with the way this problem works. So we're going to graph it first. So the first one, y equals 1/2 x plus 3. We know we got a slope of 1/2 and a y-intercept of 3. So we'll go over to our xy grid and graph this. So we place a dot at 3, 0 over 3 up, which is the y-intercept. And then we're going to go up 1 and over 2. Our slope's 1 over 2, rise over run, so up 1 and over 2. And then you can also go in the other direction. I'm putting a lot of points in because I want my line to be as straight as possible. So we draw our line in there. So that line is y equals 1/2 x plus 3. Now we're going to look at the other equation, and on this one I'm going to go ahead and use the xy intercept method of graphing. So we have 2x minus 4y equals 12. The xy intercept plugs in 0 for y to get the x-intercept, and then 0 for x to get the y-intercept. So the first thing we're going to do is put in 0 for y, so that gives us 2x minus 4 times 0 equals 12. 4 times 0 goes away, so it's really just 2x equals 12. So we divide both sides by 2, and x equals 6. So one of our intercepts, the x-intercept, is 6. 6 over 0 up. Then we put 0 in for x, and we get 2 times 0 minus 4y equals 12. So that gives us negative 4y equals 12. So divide both sides by negative 4, and you see that y equals negative 3. So our y-intercept is negative 3. So the x-intercept is 6, the y-intercept is negative 3. We go over to our graph, we go on the x-axis and move over 6 units to the right and make a point. That's our x-intercept. And we do the same thing. We move 3 units down because it's a negative on the y-intercept, and then we connect the dots. Now if you look at these two lines, it doesn't look like they're going to intersect. You know, when you solve by graphing, you're looking for the point where the two lines intersect. But it looks to me like they're not going to, that the lines are parallel. In fact, we can't be 100% sure they're parallel, but they look like they're parallel, and so it's a pretty good guess that they are parallel. Before we go on and decide what that means, let's consider it by using substitution. That was graphing, so now let's use substitution. So it means to do that, we're just going to put 1/2 x plus 3 in for y in the second equation. Just did a little substitution. We already solved for y, so I made it easy. Now we need to do some multiplication. Make sure you realize you're multiplying by negative 4. So it's going to be 2x plus a negative 2x plus negative 12. Well, what's interesting, the reason why we did this by substitution also is 2x plus negative 2x is 0. The x disappears. All you're left with is negative 12 equals 12, which is not true. Okay, and that means that there is no value for x and y that make both of these true. So we write no solution is what we say for that. And at the same time, we now know that the answer was, yeah, the lines were parallel. Okay, they were parallel, which means they're not going to intersect, which means there's not a solution. We can prove that by taking that second equation and solving for y and looking at the slope. If you remember from earlier in Algebra 1, if two lines have the same slope, then they're parallel. So let's solve this for y and see what happens. When you subtract 2x, you get negative 4y equals a negative 2x plus 12. Divide both sides by negative 4. You got to divide everything by negative 4. And you have y equals, well, negative 2 over negative 4 is 1/2. And then 12 over negative 4 is a negative 3. So you can see that both of the equations have a slope of 1/2. They have a different y-intercept, which means the two lines are parallel, which in turn is another way of knowing that the answer is no solution.